Right, I'm going to do a repair and restoration on this thing. This is a Keithley 225 current source. I haven't powered this up yet, I've done nothing at all with it. I've basically unboxed it when I got it and had it sitting around for a while. Things like this power cord is knackered, you know, the actual wires are exposed in here. This is like super dangerous. So yes, it needs a bit of work. These knobs are a bit yuck. They've got like residue on them and these need to come off, I think, and be cleaned properly. I'm a bit concerned that maybe the plastics are failing, so that may be a problem. We'll see. Hopefully I can restore them and keep them nice. It may be a case of cleaning them up and then maybe coating them with something to stop the air getting to it, or UV and what have you, because it could be the plastics just on the last legs, I don't know. But that's going to be a problem, because otherwise you can't read what the digits say. On the back, I've already changed to 240 volt, or 230 volt, which is the option. Oh, let's get one of these. That's nice. So I need to replace this power cord. I can't plug it in its current condition. It isn't safe to do that. The power cord itself might be alright. I might just need to put a plug on the end of it. But then the fact it's split and done this, maybe it won't be. I don't know. I mean, I don't know. It seems kind of okay. It looks like it's just about the end there where it's been stressed. Anyway, we'll open this up, see what's in it. Also, if it's your first time here, don't forget to click like and subscribe and click the bell icon. Because those sorts of things mean you get to see my future videos. And even follow-up videos. If I don't do this in one video, then you might want to see the follow-up videos where I do fix it, hopefully. Make sure you click subscribe. I hope it's not a total disaster in here. Who knows? I don't even know how old this thing is. I think I've got a electronic manual for this, like a PDF or something. I think I've got one. I think I have. Don't have a physical manual. If I can get a physical manual, I will actually get one. Okay. Interesting. There's what's inside. So the PCB is actually suspended, so if I need to get the bottom of the PCB, it looks like I can take the bottom cover off. There's the rest of the PCB there. So actually, maybe I should do that and just check this. This is interesting. Maybe it just latches in. Some things do that. Yeah, it's a latch. That's unlatched, I think. Oh, look at that. How's that for design? Oh yeah, this one just wasn't put in the right place, so it wasn't actually latched anyway. Okay. So look at the bottom. It's got a spiral cap in there. No reefers here. Well, at least not on the bottom of the board. It's got a couple of carbon resistors in there that may be in need of replacement. But on the surface it looks okay. Nothing's jumping out being, you know, something I need to worry about. This wiring on here is a bit interesting though. Mains wiring is the only thing I'm looking at, which looks a bit dodgy. Looks like someone's already replaced the cable once. Or done something with it anyway. Decent sized transformer. Windings aren't very tightly patterned, I don't think. I don't know. It's interesting. Couple of paper caps. These are interesting. I'll have to look into those in a bit more detail, I think. So C206 and C205 they're called. I'll have to look at those, find out a bit more about them. There are no markings that I can see. That always makes it interesting. But otherwise it actually looks quite nice in there. A little bit of surface dust, not much. So there's a few electrolytics in here which I should probably look at and see if they actually need replacing. They probably do. Alright, so we'll look to see what we've got here. C211, 141 microfarad, 0.09 dissipation. Oh, on the surface that looks alright, but it's in circuit. ESR 1 ohm, yeah, it's probably alright. Now these axial Phillips, well these blue caps, I think they're Phillips caps anyway, they're blue. They can be problematic. It's another 140, 0.8 ohms, 150, 1.4 ohms. Just measure this one again. I did this one backwards. It probably doesn't matter, but I just want to do it anyway. Make sure it's always the same. Yeah, okay. So there are some differences in these caps. 1.4 ohms versus 0.8 ohms for the one next to it. So they're all varying very slightly. Value is supposed to be 100 microfarad, 40 volt, at least on two of them. I can't see the third one. That's 100 as well. So they're basically all up by like 40 to 50%. Being slightly higher, I wouldn't be too worried about, but 50% higher is getting up there. I think that's a sign of these caps being too old. They need to go. So I've been looking around, just checking the circuit diagrams and just verifying some things. So these capacitors here aren't too critical, they're just cross power supplies, just smoothing. I've also got these tantalums up here for extra filtering. I'm not going to worry about changing tantalums, they're probably fine, I've got no reason to suspect them, at least not at this point. These capacitors here are still a bit of a mystery, but these are basically 140 microfarad, 150 volt caps. These are across a 130 volt power supply line. So it's quite a critical section. I don't think these are any good yet. I'm going to do some testing. I might just chuck a multimeter across them, see if I've got leakage through a multimeter. Then I'll check the capacitance as well. And I don't know, if they measure okay, they don't seem untowardly bad, I might leave them alone. I don't know what the hell they are. But, some kind of electrolytic, well, at least they're polarised capacitors at least. Maybe not electrolytic, but they're certainly polarised. Yeah, I don't know. It's interesting, I'm not familiar with them. Maybe it's a wax or oil capacitor or something, I don't know. What I want to do first is check these bridge rectifiers. There's 3 bridge rectifiers, I'm going to check those, make sure I look okay before I do anything else, just before I forget about them, because I won't forget about doing capacitors. So I've got caps here ready to replace those 3, and I'll measure these. So I'll test those first, replace these 3 caps, then we'll test these and see what they come out like. And if it all looks okay after that point, I will have to find another plug. I used one earlier already, I don't know if I've got another one. I think, yeah I do have another plug somewhere. And putting your plug on this lead, we'll then be able to power it up and see what happens. But first things first, let's do some more testing. See my newly modified 175, which has got a backlight button. Bet you wish your 175 had a backlight button. Diode test. Actually I might shove this over here and adjust this for you slightly. So, chest of diodes in this bridge rectifier here. Nothing. 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 That looks good so far. That's fine. That's fine. That one's all good. Next one. Yep, all the bridge rectifiers look good. So don't have to worry about those. Nothing untoward's happened, probably. Because usually you get a major power supply fault, those little bridge rectifiers, they will blow. I've seen those very similar ones to that, at least. The same physical package and size, but different type. I've seen those blow in the Datron multimeters. I like to check those round ones because I know they do fail quite easily. So I'm going to check now, actually, whilst I've got the meter here and everything. Let's check these capacitors because they're interesting. But they do actually have 4 terminals, which makes them even more interesting. There's no short. I'm assuming I'm on the right terminals here. That's charging up. What's that terminal doing? It's the other way. Okay, so that terminal there is connected to this one. These are linked together, which means this one here should be the same. It is. So I'll try and show you what I'm doing on the camera. Get you a better shot. So can you see this one here, that terminal there? Yep. So these are the 2 main terminals, and this terminal here is also connected to this one. These are the 2 connections. They're common. So that must be like the negative rail, or the negative side of the capacitor. That one's probably negative as well, is it? Yes it is. So that one is likely the positive. I've seen the same, or very similar setup on the Fluke 343A. So the Fluke 343A had very similar style capacitors where they have 3 terminals which are all connected together. So that's exactly what I was kind of expecting. And then one which is separate, which is this one here. So it could become positive, could become negative, I really don't know. But it's passing through the capacitor, so if I do check these capacitors out, I will have to add links between these to make sure that these don't get missed. Because it is basically passing through, it's using the capacitor as a jumper because there's a whole bunch of tracks come through here. And so it's going one side through the capacitor, back up the other side. So it's acting like a jumper. Right, so if I do replace these caps, then I need to make sure that I put links in. Right, so I was checking this capacitor here. It's reading 120 microfarad, 0.2 dissipation. Let's see what the ESR comes out as. 0.3 ohms. It's not looking that horrendous really. Capacitance is down though. Stick that on there, stick this one on here. Yeah, here we go. 120 microfarad again. Ah, mind you, I'm at 1 kHz, I've got the wrong frequency on here. Wish this thing would default to 100 Hz. So 0.3 ohms. Okay, just go down to 100 Hz. This might explain why. There we go, 135 microfarad, 1 ohm ESR. And dissipation, 0.09. That looks absolutely fine, really. These caps might be absolutely fine. We'll do this one again because I messed up the frequency. 135 microfarad, 0.09. Yeah, it looks alright. ESR, 1 ohm. These two caps look exactly the same. So, the fact they're both exactly the same, there's nothing there looking bad, I think they're fine. I think I can avoid having to change those for the time being. I've got no reason to suspect them. Good. Don't have to mess around with them. So I was just discussing stuff with the live chat people, and in the live stream I'm doing, last time recording this. So we've got these 4 tantalums over here, which you can kind of see if I get the lighting right, maybe. I just measured these for shorts and stuff like that. There's no shorts on these 4 tantalums, they're all absolutely fine. These are a 12 volt rail each one, plus the 12 volt rail, and there's a 35 volt tantalums. So they're like basically triple the rating, which is fine. If they had 16 volts I'd be really worried about them. 25 volts I'd be a little suspicious. 35 volts I'm pretty comfortable with. So they're probably fine. They're not likely to have ever been stressed to their limits. What tends to happen, at least this is what I believe is what happens, is you'll get a power supply issue where you get a lot of ripple coming through the rails because the electrolytics let go and the electrolytics stop smoothing the supply rails out properly, and then you get a lot of ripple coming through. And that ripple voltage then stresses the tantalums, which then makes tantalums blow up. So that's what I believe is what happens with them. So having a big tolerance on them is very important. You know, if you're close to the supply rails, you're likely to get an excessive ripple voltage on across them, and then it will stress them and they blow. They don't like being over voltaged. Right, let's get this thing out. It's bent over, of course it is. Very slightly. Okay, it's moving around, so it's free. I've just got to get it out. There's no trace on the top of the board, so I don't mind giving it a pull. Yeah, does not want to come out. Just like a lump on the end of these legs. It's almost like they've been squashed flat. Like they've been crimped. Yeah, let's do this. Look at that, that's much easier. New capacitor. So this is slightly higher voltage rating, same capacity rating. Just got to try and pull these leads a bit tighter because they're slightly bent. We've been trying to get it lined up to the holes. Can't solder it yet. I'll do them all in one go. Let's get these top ones out. They're up here. It's probably got the same problem, they've been crimped. The tool works on these legs, so it squashes it a little bit and cuts it off. So maybe it's a special tool I use for that. So I'm going to have to cut these off like this. Hopefully not these bits go places. There we go. There's one. And there's the other one. Okay, let's put these ones in. I'll get these positioned, I'll come back. So a few years ago I built a high voltage leakage tester. Just an Arduino project. Used a voltage multiplier circuit. Pretty simple design really. I actually sent one to Julian Illet and Big Clive. I sent them like some chocolates and a cup as well. Turns out Julian doesn't drink coffee, so the cup was no good to him. But Yeah, so that's an interesting little project. So you can actually hook it up to capacitors and see what the leakage current was in them. Solder these in. So that's something I can actually use on these caps, for example, and actually see how much leakage there is. But actually, I'm going to stick some flux on these. This is old. The thing, I've got it in my drawer over here. I've actually got it here. It works. Just got to plug it in and use it. So soldered. That should be good. So that's that part done. Those capacitors changed. Big caps I'm fairly happy with. Like I said, they looked alright. I'm not worried about those. I mean, I would like to change them. I don't have a reason to though. So in the back here, this wiring here for the power cable, it's not great. It's pretty badly soldered, so I'm just going to fix these up, make them look a bit nicer. Just because someone's obviously been in here, done this, and it's not great. It doesn't have a factory, certainly. So it's got fusing on this side here. Which wires which? This is a voltage section switch, so it should be primary coming in here. Yes. Onto that side. So then goes through to the transformer connections. And this one here, which is fused, where does that go through to? So you've got this red wire here, which then goes through into this here. Okay, so that's the cable goes down to the front switch and down to the front board here. Then he's come back here, back over here to the back end here. How's this thing set up? I'm just not convinced somebody else has done this right. So you've got a wire going to transformer down there, wire there, and a jumper link there to this one. So those are the two transformer windings. That's a link to extend it. So when it's in this position, it shorts those two out. And that's to 30 volt position. Yep, that's right. So that's what I expect. So that makes those go together, otherwise they're in parallel. I'm pretty sure that's right. I just want to double check that. So after soldering this, I've decided I don't like them. These wire colours aren't right. I've traced it through and we've got black and brown, which aren't the right colours anyway. It used to be black and red is the really old colour scheme, and brown and blue is the current colour scheme. And it's a mixture of both, and they're backwards, so black is actually the phase and brown is the neutral in this case, based on the wiring and the unit. So I'm not liking that, so I'm going to take the cable off actually and replace it with another one. Right, let's take this wiring out of here. Now I know where it all goes anyway. This one's pretty awful. So neutral will go over here, so this bit of blue wire gets attached to this post, which has got a piece of wire attached to it still. They didn't do a very good job on that. This one here will be going the brown wire. Should put a bigger tip on this. You can do it. Here we go. There's a wire still attached to this as well. Yeah, there is. So I did that before, just cut the wires off. Interesting. And earth is earth. Right. Come on. Here we go. That can go in the bin. New cable. That gland was pretty tight. Hope I can get it back in again. So I want to make sure I've got plenty of wire to loop around, but not too much. So I've got to get it to here, into here. So yeah, don't want too much inside. That'll do, I think. Right, so I can crimp this down and get it in place. Can I squash it enough to get it in? Can I pinch my fingers? Quite likely. In fact, I'm quite likely to pinch my fingers. Actually, let's do this. Try and squash it down first. Get the cable deformed. Improve my chances. And that'll be my wife. I should probably go and check that as soon as I can let go of this thing. Come on, in you go. Come on, get in. Get in. Right, so I've got the gland back in, much persuasion. I now have, well, I've purchased the correct tool for the job now, because I don't currently have the right tool for the job. I've just purchased that on AliExpress. I purchased one of the most expensive ones, so it should be decent. No guarantees there. There's, or much no, that's just, I mean, it's not something like I use all the time anyway. Slice this thing, make the plier job is not working. I'm not going right down, I was scoring the outside so that it will tear along that line. That's the plan anyway. Because if I damage the internal wires, I've got to strip it back and do it again. This has got the right colours in it. What's all that? Okay, so this needs to come back some more, I think. Yep. Don't slip, don't slip, don't slip, don't slip. I like my fingers, I like my fingers. So the earth wire should be the longest one. These can be cut down shorter and those reach nicely from there. So I think I might take down very slightly more. This I'm going to leave long. I wonder if I should try and get those other wires stripped out. That's already left in here from the other guy. It looks like they're wrapped around. That's probably why I left them on. Too hard to get them out. Let's get a wire stripper. These are the ones I've been avoiding getting all day because it's so hard to get them, you know. Yeah, I've got to cut these ones down anyway. Smoky. So this one's got to go to the switch, so it needs to stay quite long. I'll do it this way, then you can see the depth. Right, so that's got to go to the switch. This one only has to go to here, so I can cut this one down quite a bit, and all you get is shorter to go to there. This is a bit smoky. Wow. Because it's got the iron temperature up quite a bit and there's quite a lot of flux in this one. Okay. Let's get these attached. So I've already attached the earth wire. I'm just putting on the phase wire now, which is the brown one. I'll put some heat shrink sleeving over the wire, so when I've put it on I can slide the sleeving over and help to cover the connection up and make it a bit safer. Wherever possible, we should always try and cover up mains connections, just to improve the chances of a bit of safety there. You know, maybe one day you save yourself from electrocuting yourself, or somebody else even. Okay, that's on. Slide the sleeving over. It's not a big thing, but it helps. Now, that's not exposed. This one here still is exposed. Right, so that's still a risk. So I'm actually going to put one over that as well. I think I can just have that cable running down the back of it, like that, and then sleeve over the whole pair. You just heat shrink that on there. If it works, then great. Yes, that is hot. Okay, now no touchy. No live things to touch. Better. This is still live over here though. It's still something. So now we put the neutral on over here. Got to attach it to this point here, which is looking fairly ugly to be honest. The last guy made a mess of it. I was thinking about, should there be something in between these terminals to insulate these terminals from each other in case they got bent down or something, but I don't think it really needs it. I think it's right. It's not loose or anything, so probably good. Right, we get in there. Almost to the point being powered up. Once I put a plug on. I forgot to record the video again, so you've missed my plug rant once again. My ranting about how crap these Xenon plugs are, the design, the way it doesn't actually work properly. Like you undo the screw and the thing doesn't actually open up like it should. You have to jam a screwdriver into it to make it open up so you get the nut open so you can get the screw undone. And anyway, these wires are now in place. So I've now made this so the earth wire is longer than the rest. So this should be the last one that pulls out if something goes wrong. Now this just literally just pushes in. It's like, it just hooks onto this edge here. It's rubbish. No screw retaining. It just pushes in. Like, I don't like these plugs. Whose stupid idea was this? What idiot came up with this design? It's like the worst design ever for a freaking mains plug. You can yank on these things and you rip the cover off and rip the wires out the plug and you've got exposed terminals. Right? It's just absolute garbage. And this meets New Zealand standards. That's fine. It meets the standards. It's alright. It's not right. It's crap. There you go. You got something around. Happy now? There we go. That's just pushed in. Literally is pushed in. That stretchy cover here is the protection. Right? And you push this down as much as you can. Like that. And then you wind this down and it kind of grips. Kind of. Not well. The cable still moves. You wind it down some more. Cable still moves. So the cable clip is, you know, awesome. You keep going down like that, and the cable still moves. You keep going down until you can't turn it anymore, and the cable still moves. Okay, I screwed up. I will go to 50mm. Reason being, these hooks in here, the wires are supposed to go around those hooks to form a strain relief of sorts, like that, and provide a strain relief of sorts. But it's still crap because it's still going to pull on the wires. It just reduces the stress on the wires slightly, but it's still going to pull on the wires. It's still a crap design. Here we go, like that. And like this. Okay. It's still crap. There should be no pulling on the wires. Alright? The wires should not get pulled. If you're pulling on the wires, it's wrong. The strain relief on the entry is what's supposed to take the strain. So it's on the housing and on the actual main cable completely on the sheath. If you're only pulling on the inside, the sheath will get the sheath will get stripped backwards and as it gets pulled, and then it will expose the inner conductors on the outside of the plug. It's still crap. Yeah, it's just, yeah, anyway, we get the idea. I don't like these plugs. All these New Zealand plugs are rubbish. Oh, man, I'll try and get it back on again now. There you go, went on easy the second time just because I stretched it a bit. Put it in it, fall off and so someone yanks on it. Shouldn't be relying on pulling on those conductors to stop the plug being ripped off. It should be on the sheath. Yeah. Right, so now we've got a mains cable hooked up. I've done some tests on it, make sure it looks okay. There's no earthing issues. There's like 0.1 ohm to the front panel and BNCs and stuff like that. It's all absolutely fine. No apparent shorts on the transformer. All looks normal. We shall try powering up for the first time and see if anything goes horribly wrong. And then if that works, we can do some more refurbishment, like cleaning up these knobs, take these knobs off, clean these up, then try and figure out how to use the thing and actually try using it and see if it works. May not even work yet. Got a hopping meter over here, power over here. I better make sure I've still got it set to 230 volt. I do. Power switch on. Ready for the bang? There could be a bang. I'll step back so you can see the hopping meter. 5.6 watts being used. Power factor of 0.39. Not a lot happening. No bang. No smoke. Well, that's boring, isn't it? Right, let's play some controls, see if anything actually changes. So we've got LED on over here. This is standby modes. Negative, positive. So, okay. We've got compliance voltage. Nothing horrible happening. Let's go positive. Wind this up. I'm just watching the current, the power usage on the meter over here. Nothing horrible happening there. These all set to 0. That's on milliamps. Alright, so you can see the LEDs changing, although this one didn't come on yet. Is that LED there blown? I can't actually see what this says. This says nanoamps, microamps, milliamps. Is that? No, it's microamps again. Oh, there you go. It just came on. So yes, the LED was supposed to be on. So I guess the switch needs cleaning, because it wasn't until I was doing that and it came on. Yeah, now it's working. I don't know, maybe it's a bad switch or something else. Right, filter off. Right, give it 40 volts, whatever. It's got a limit over here. That's to that. Oh, let's see a little voltage spike just then. Or power spike, I should say. Right. Nothing else. I guess it was charging something up at the time, and now doesn't need to do that. Okay. Negative. It went another power spike again, and it went back down again. Well, that's interesting. So in standby, it's using more power. So there it's using 5 watts, or 5.6 or so. There it's not. So as I wind this up, in standby mode, it's increasing the power over here. So at 9 I'm getting 18 watts out in standby on those two positions. But in negative and positive, it's not doing that. So is it dumping that power somewhere? So it's still generating the power but dumps it? That's interesting. I don't know how it works yet. It's doing something. Right, let's see if this will do anything for me. I think I've got this hooked up correctly. Let's find out. I've got this set to 1 only. Set milliamps, but you know, yeah, okay, we'll see. Turn it up on. Got a voltage here. Positive. Let's wind this up and see if I can see anything on here coming up. Well, it should be 90 milliamps. Oh, I'm on AC. That won't help. DC. 90 milliamps. Look at that. It's working. 20 milliamps. Perfect. Nothing? Perfect. 10 milliamps. Perfect. Let's go down one. So that becomes 1 milliamp. That's right. 9 milliamps. Perfect. It bloody works. And that's at 40 volts. So if I just try changing the voltage, see if that changes. Absolutely fine. Didn't change. It looks like it bloody works. Let's change to a milliamp. Now I'm comfortable it's not going to get like a chuck an amp through it or something. I'll change this one. Okay, now I'm on a milliamp scale, or milliamp range, and there we go. Wind the voltage up again. Yep, didn't really change across the range. It stayed rock solid, like it's supposed to. 3 milliamps. Yep. 1 milliamp. Yep. Let's go down lower. So what's that? 100 microamps, is it? Yes. 10 microamps. Yes, it's showing up. So that'd be 1 microamp, but that's outside the range of this thing. I need a better meter for that. My Siglent could probably do it. But it looks like it's working. Excellent. So I've just done some testing on the currents on my Siglent as well. It's looking really accurate, it's looking very good. It looks like this knob's not in the right place. You turn it right down, it goes to basically 10. You turn it all the way up, it goes to over 100. So I actually think that the knob's slightly misaligned. If I go slightly above on basically all these ranges, then it's about the right place. So I think the knob's in the wrong place. We've got to take these off anyway to clean these up, because these are almost unreadable. So we'll do that next, I think. Find out how to get these knobs off. There's a grub screw just there. Excellent. So I've set them all to 9. There's 2 grub screws on this one. Yeah, set them all to 9. So I know where they should be. And that'll fully that way. And we'll pull these knobs off and clean them up. So I was taking these knobs off now. These are really easy to get off. I'm using a 1.5mm driver here, but I think they're not quite that. I think they're slightly bigger. So this might be an imperial size or something. I might have to get that inner one off as well. We'll see. That's sprung. Oh, that's interesting. What's that sprung? That's to create drag. Am I going to have this thing go flying off at me when I undo this one? That's a different size. Of course it is. It's a size I probably don't have. So here's my iFixit kit here. The very first bit I tried. Looks like the right one. Okay, that was good. And there's another one here as well. Pop that off. How many screws are there? 2? Yeah, there are 2. So that's now loose. That's loose. Come off. There we go, it's just a bit tight, it's winding itself off. It's got a plastic shaft. Then this has got a spring behind it. Interestingly, but look at how good that is in the back there. This all needs cleaning up really badly. So this one here I've actually cleaned a little bit already before I even recorded this video, before I did anything with it at all. Is I actually give this a bit of a clean because I was worried about how these looked. And this one I haven't touched yet. You can see the big difference there. It's basically opaque. You can't really see at all. In this one you can see the numbers. So all I really do is I've got a bit of cloth or something behind it. I think I'll just give it a bit of a wipe around the back. So I think it just needs a gentle clean up on the back here. And get rid of the residue that's on the back. And it might be enough to give it enough contrast to be visible. So again, I've got to be really careful though, because I don't want to accidentally scrub these numbers off, because that would be annoying. So literally there's a bit of tissue and it's given a wipe like this, and that is making such a big difference just by doing that. No cleaning solution at all, just a bit of tissue. That's made a huge difference already, just doing that. So I don't know what that residue is. It could be the plastic breaking down. It is possible that's what it is. So I did the same thing on the top side. Oh yeah, look at that. I'm suspicious it's the plastic breaking down and it's monomers dropping out the plastic. But yeah, look at the difference on that now. Huge difference. Put it on desk, probably see. You see it on desk, there we go. Compared to that. Excellent. Just give it a wipe, might be enough. So you've got this waxy residue, and I'll scrape my fingernail. See this all coming off? That is plastic breakdown. I'm absolutely sure of it. That's monomer spitting off the bloody material. All plastics age and break down, right? So depending on the environment they're in, the temperatures and that kind of stuff, UV exposure. Yeah, it's like, yeah, it's not meant to be like that. Yes, because it's on the front and the back, it's not just one side, the front's also got it. So I'm pretty sure it's not just some environmental gunk on there. I think it is the plastic itself breaking down and shedding slightly, and it may be that where the lettering is, it's actually helping to protect it a little bit because it stopped the air getting to the surface. But that won't last, that will eventually fail, if that's what it is anyway. I'm pretty sure it is. Anyway, I'll finish cleaning these up and I'll come back. So there we go, I've cleaned the knobs up, they're looking much better now. As you can see, you can actually read the things now. You can see this says nanoamps, and that says milliamps, or microamps, see? And that says milliamps. You can actually read them all. So that's those. I've got to take this knob here off yet and just redo the alignment of this one because it's not in the right place. It just seems like it's very slightly out. And I also need to clean all the switches yet. So I don't think I'll bother recording video on that. You get the idea. I get some jogs here, I'll spray it around on the connections, move the switches a bit. Not much to it really, like all these switches and this multi-way switch here and this pot here would also need doing. But yeah, I think it'd be good. So don't forget to click the like and subscribe if you like the video. Click the bell icon as well so you notifications about new videos and other things. If you want to become a Patreon supporter to help me buy bits of test gear to fix and do refurbishments on, like this one, then check out the links at the end. So we've got a playlist over here for something else to watch, another playlist over here, subscribe link right there, and a Patreon support link over there if you want to go and check that out. Bye.